sorry. This is not working. Okay, working. Oh. Okay.
Use this one for right.
Yeah. Okay, thank you.
The other one for left.
Not working. No.
Yeah,
Some slowly?
Introduce this.
Oh, okay. Okay. Thank you for waiting. First, I'd like to introduce myself. I am Kanahiro Iguchi from Japan. I call myself a GIS OSS enthusiast. I love FOSS4G and open source softwares. I wrote some codes and published them as open source softwares. And I am a member of MapReview user group Japan. And one of the I worked as a CTO at Mielne Inc. Okay, Mielne is a tech company in Japan specialized in geospatial technology. Mielne located in Sapporo City in Hokkaido and in Japan. Prizren is here, so the distance is about 9,000 kilometers. It takes about a day. Mielne supports communities. Mielne is founded based on FOSS4G community and so supports some communities like this. QGIS.org. Mielne is one sustaining member for QGIS.org. Mielne is a first sponsor for MapReview organization. And one founder of Mielne is selected as AWS Heroes for his contribution for AWS open source softwares. Our solutions, first QGIS, and today's topic. We can develop QGIS plugin to fit customers' needs and provide some supports about consulting, seminar, and so on. Next, WebGIS. We can develop full-stack WebGIS applications, of course, including client-side and server-side, with great performance. And MapTyra. Mielne is a Japanese agent for MapTyra, so Mielne provides support for MapTyra's products for Japanese customers. And also, in addition, Mielne creates beautifully styled maps, especially for MapTyra crowds. Please check it. And Mielne Base, I've talked about this. Mielne Base is a geospatial software service is now underdeveloped. The concept is to store, edit, and serve your GIS data from Mielne Base cloud. Our message is change the world with geospatial. Okay, let's get down to my talk. Today's contents. Okay, first, about GTFS. Do you know GTFS? Please raise your hand if you know. Wow, thank you. Many people already know, so this is maybe not needed, but GTFS is a dataset for public transportation, including bus, subway, ferry, and so on, any type of public transportation, and stands for General Transit Feed Specification, and is a specification defined by Google. And recently, GTFS RT means real time, becomes popular. This is a spec to stream real-time location of vehicles. But today's talk about GTFS, static GTFS. GTFS consists of some CSV text files, named agency, stops, routes, trips, stop times, and memory, simply text file. GTFS is readable for computers because it is simple table text, but not for human. Stop times, this is stop times text, but stop times table expresses time for vehicles to arrive at each stop. Then where is the place of each stop? Can you understand rows in red square mean one route? This is not understandable for human. And GTFS tables are normalized like relational database. So it is difficult for humans to read or use them. So we need an application to utilize GTFS. This figure is quoted from Wikipedia. This is very simple. Which software does use GTFS? Google Maps use GTFS. When GTFS is created, the roots of GTFS are shown as candidates in the root search. To be candidates in Google Maps is the biggest motivation for public transportation services to create GTFS. But on the other hand, there is no big use cases of GTFS in Japan other than Google Maps. But GTFS has many interesting traffic data, such as timetables, routes, and place of stops, and so on. And moreover, many of them are distributed, mainly distributed under open license as open data. So it is great that GTFS becomes widely used even outside of Google Maps. This is the motivation to develop GTFS Go QGIS plugin. GTFS Go is a QGIS plugin to easily visualize GTFS. GTFS Go has two features. One is visualize routes and stops. Second is aggregate traffic frequency. This is an example of GTFS Go output like this. And this is output of GTFS Go. GTFS Go has an easy interface, and you can utilize GTFS with few clicks if you have GTFS data. And first feature, visualizing routes and stops. You can pass GTFS data and convert it to QGIS vector layers. Then you can design maps of public transportation in QGIS like this. This is an example in Japan. Next feature, aggregating traffic frequency. This is an example of New York GTFS. This visualize how often past each passes. And then gray lines have different widths. Border lines mean more frequent paths. Then you can see real values of frequency in numbers aside lines. This is demo movie. Please wait. Moving. Please wait. This is not moving. Stopped, but okay. I skipped this. If you have time to indicate this, after I try it. Use cases, GTFS Go enables you to analyze public transportation with other GIS data. This figure is output of GTFS Go, and red meshes indicate populations in each area. Then question, visualizing like this, then a question occurs. Is the amount of traffic in this area appropriate? Too much or not enough? Visualize, make us realize problems and accelerates discussions. I believe this is the power of visualizing. This is Japanese use cases, Japanese paper in Japanese local government uses such an example. Next use case, this is tweet in Twitter. Some people use GTFS Go to visualizing GTFS location and frequency. And these are very many Twitter users reacted these tweets. And then GTFS Go is published on QGIS plugin repository, so you can install from it. And star is spiked when Twitter is many people reacted. And GTS Go is published, developed under open source software licenses in this repository. GTS Go has 2 licenses. Core module GTS Parser is under MIT license, and other is GPL. Welcome every contribution. You can install it from QGIS plugin repository from your QGIS directory. Okay, let's get into technical talk. GTS Go uses pandas, heavily uses pandas. And GTS Go consists of comma-separated value text files, so it is good to convert them into data frames like this, and stops times, roots, trips, and each text file into data frames. Basically, GTS Go export 2 data, stops and routes. Stops is simple. I can make stops data from 2 tables, stops and routes. But routes is somewhat complicated. I need 4 tables and joining, and merge. I get 1 table, 1 big table. I need to do so. Then it was challenging to understand roles and relation between tables. I can understand. I knew I was able to connect each tables by ID, and stop ID was root ID and so on. But I didn't know which tables should be connected to achieve data I want. For example, I want to stop data, but which tables are needed, I don't know. Next, GTS has many optional values. And there are many optional columns, nullable columns, and even optional tables. This is makes GTS very complicated. For example, shapes.txt is optional. Even this indicates real traffic routes, but this is optional tables. And then, so I had to deal with cases where one has optional value and another doesn't. This is complicated. Next, this is about aggregating feature. In GTFS or in bus stops, there are typical cases. There are many similar stops which could be treated as a group. This 2 figure indicated this pattern. Left pattern has there are 2 stops and has the same name. This is across the road. And to aggregate traffic frequency practically, it is better to group such similar stops into one. Right pattern is better to aggregate. Then I defined the similar stops as have same parent station. In GTF specification, stops may have parent station as optional value. And in this case, stops are moved to the position of parent station. This is very simple, but not many stops has parent station. And next, have same prefix in stop ID. Among GTS providers, at least in Japan, there seems to be a custom that stop ID is named with the same prefix, such as who_1, who_2. These could be grouped as a group who, bar-a, bar-b. These could be group bar. In this case, stops are moved to the centroids of such similar stops. Third patterns. This is most complicated pattern. Have same stop name and are near to each. You can see many cups of stops that have same stop name in area. This figure, behind me, and across same name stops and across the road. These could be treated as a same group. This is complicated. How is complicated? Third pattern. So I'll detail this pattern. Left pattern means there are 5 points left figure. 4 have same prefix PyCon, and 1 is not. Then I want to move them into the centroid PyCon stops, but left stops is distance from other three. Then I want to move only 3 points into 1 point. Then I have to think about this, how to judge whether the stops are near or not. This step in GTFS, I judged with these two steps. First, extract same named stop. This is simple. Next, calculate distance from the centroid of them. This is a core. Using longitude, latitude, Euclidean distance. Then I calculate distance in long lat plane. So in GTFS, Earth is flat. And this is not precise distance calculation, of course, but not problem in this case. A precise distance is not needed. Only a good threshold is important. Next, more appendix, more complicated technical terms. Aggregate similar steps into traffic frequency. There are no path table in GTFS, so we make it. Input is a table of stops. Left bottom table is a very, very simple example for it. I convert it to right figure, path into path table. Each row has from to geometry. I can aggregate frequency by count distinct the number of paths, like such geometry number of paths. Next, Python and Panda performance. Initially, my implementation was not good, very primitive implemented, and took long time to calculating. But by tuning to follow the best practice in Pandas and Python, the performance was improved. First, anyway, avoid for loops. For loops is very slow. It is better to use column table-oriented methods like map apply provided in Pandas. And memorization, next memorization for methods. In GTFS, there are many methods could be thought as a key value. Then functors error cache is very useful. Okay. Let's wrap up. GTFS Go is a tool to analyze and visualize GTFS, and Pandas is good for GTFS parsing. And it is important to follow good practice. Thank you. That's it.
Thank you so much. Thank you. Are there any questions? We have maybe 3-4 minutes, or you can go and talk to him directly. Any questions? Yeah, just maybe one question, and then we move to the next one.
Thank you very much. Do you plan to maybe kind of use it also for WebGIS and transfer it, because you've done it for plugin? You've done it in plugin, but maybe it could be very nice also to have it for the web version. And I guess it would be also very useful in that sense. Transferring into WebGIS and
yeah, I have think about it. I tried, but it is not implemented yet.
Okay, if you need some help, just let us know. We're gonna try to.
Yeah,
we can collaborate. Thanks.
Thank you.
Anyone else? No. Okay. Thank you.
Thank you.
right, over to Marco for QField Cloud.
So, hi everybody. I'm going to talk about QField Cloud today. What I'd like to do is show you with a lot of slides in a fast pace, basically what your full workflow with QField Cloud could be. For the ones that do not know QField Cloud or QField, QField is an app to digitize data on the field. I'm just waiting for the slides to appear. So, QField is an app to digitize data on the field. There you go. And we obviously thought that at a certain point people want to get their data easily from the field back to the office. Why did we do that? Because QField is basically taking over the world. As I mentioned in the keynote yesterday, we are at almost 850,000 downloads. We're doing 20,000 more downloads per month. So it's a huge user base growing. And we actually put a demo project in QField where you can digitize yourself and tell us where you are. That's what comes out of it, basically everywhere. We are now at version 3. I'll get there. 2.8.3. And this morning, probably you saw the presentation by Matthias with all the new features. If not, come by to our booth. We can show you a live demo of what we have there. The idea of QField is that it needs to be there for you when you're online, when you're offline, in bad situations, and when you have teams and roles and conflicts. And this part specifically is what QField Cloud solves for you. So with QField itself, you can do very well online or offline. You cannot do hybrid. You have to decide. You cannot really do teams. It works very well as a field collection app, but if you really are starting using teams and those features here, QField Cloud is really going to enhance the way that your workflow goes. It is obviously, since we believe heavily in open source, it's a truly open source solution. We've been pushing out all the code of QField Cloud as well on our repositories. So if you want to take it yourself, host it on your own services, go ahead. So obviously you log in first. That's the first thing that you'll do. And when you're there, you get to see your projects. QField Cloud is as a concept of organizations, of teams, of users, and of project. Every project has an owner, which could be a user or an organization. Organizations creation, it's super easy. Every user can create as many organizations as they want. They are mainly data management and billing constructs. So you will have your company as an organization and then add users to it. Every member of the organization can be either just a simple member or an administrator, and then the permissions that it will get is really based on the project that we'll see further on. We can build teams because we know that sometimes you have the team East that only needs to go to certain projects, the team South that needs to go to other projects, so you can really manage your users easily and adding them to teams, and then add the teams to the project so you don't have to repeat all the time the same 7 people to a certain project. In the project overview, we get to see who is involved, how many files this project has, how many changes the project had, and when we go into more details, we can go and have a look at what files are part of a project. So there is always a QGIS file, obviously, which is what gives you the styling, the labeling, and printing, and layouting, and everything. Then you will have data, possibly, geo packages, ideally, or PostGIS connections, in which case you wouldn't see them here, and then attachments like pictures that you're taking on the field. In the project itself, I'll see also all the changes that happen. So I have a track, a follow-up of what my users on the field have been doing. Here, for example, I see that Linda has been heavily working last summer when we prepared everything. And we see that she did some changes, and the changes were automatically applied. If I then go further to the collaborators, I'll see that I don't have Linda here. You saw that she was working. That is because Linda is part of the Ninjas, and she is an editor. You see here we have different permissions, and this is a really key part. We have 5 levels of permissions that you can give to users or to teams, where the lowest one is reader. Those are people that can look at your project but cannot change your data. They can just have a look, and that's it. The next level we have is the reporter, which we have for the demo users. Reporter can only create new data. They cannot go and delete existing things. They can just create new points, new lines, new polygons. And then the next one we have is the editor, which can do everything with the data, but cannot go and change settings and the QGIS project itself. Then we have manager, which does almost everything, and admin that can kill the project and those kind of things. But I think that a really interesting one, the reporter, which you can just give to an external contractor maybe to go and create data, being sure that your own data is not being touched and done anything with it. And the interesting part is that because we know in QField itself the role that the person has, we can change the user interface. We're not going to show a plus button to add a point to Lucy, which is only a reader. We are just going to show her the map and the possibility to click on it. So that's really something that, that we push a lot so that the user interface becomes even easier. When things are done, we have jobs that happen. A job is something that QField Cloud will do for you. Whenever data are pushed, they are integrated, and the result of a job is a new version of your data set or of your old project if you're doing something from QGIS itself. We can set up secrets, which is how we are working with PostGIS directly. You can set up a PG service, and whenever a job is running to integrate data, it will, instead of create a new GeoPackage version, it will push the result back to a PostGIS database using the credential that you're giving to the PG services. And this is something extremely powerful because you can have your own integration database where you are having all your people pushing data, do your quality assurance on the integration database, and then push it over to your production database. PG service, you can define all the things that you need for PG services. And once you set up everything, you know who's working on the project, you have your team, you have your collaborators, you have everybody on board, you can start working. This is usually what I just showed before, a work that one person does in the office. It's not something that you're doing very often. It's something that you do at the beginning of a project. And then you go to QGIS, you install the QField Sync plugin, and you can log in there as well. And once you log in, you'll see all the projects that you're a member of. You can you can download it. You'll see it downloads all your GeoPackages, all your images, or the QGIS project, obviously, and it opens your project automatically. You can do some changes in QGIS. You can change symbology. You can change data, any kind of things. And when you push again, you'll see that not everything is pushed. Before we had like 6 or 7 files. Now we're pushing only 2 new files. So just smart enough to decide whatever needs to be pushed and to give you the possibility to synchronize. On the other hand, if meanwhile somebody changed the data on the field and pushed and there was a job that ran on the cloud, you see that we have the possibility here to download the GeoPackage and upload the QGIS project. In the end, we will have merged both. We will have on the cloud the newest QGIS project and the newest GeoPackage, which is the new state of the project. This is one way to go. So when you're creating a new project, when you're using an existing project, if you are on the other end, never used Qfil Cloud before, you have your QGIS project, and you have optimized it for mobile, so please do not use one-to-one the projects that you have for your office. Field work is different than office work. It's cold or super hot, windy or super sunny. It's not like sitting in your office on a nice, comfortable chair. So do projects that are made for your users on the field. And in this case, when you've done that, you convert it. You can just click on Create a New Project. It will show you a mask where you can convert. You will make a copy of it because we do not want to touch your original things. We'll make a copy of it if you choose the first recommended variant. If you choose the second one, it will use the one that you tell him to use. So it's kind of the advanced version. After that, you give it a name, tell it where it is, push it, and it's up there. It opens automatically the one in the background, and that's it. At a more detailed level, so layer level, you can choose actually what happens to the layers when you're pushing them. There might be layers that you don't care about in mobile, so you can say ignore them. I don't have an example here. There are some layers that you want to directly access because they are WMTS given by your national infrastructure, and you don't want to dump the whole thing in your phone. You just say use the WMTS directly. And then we have the offline editing ones, which are the ones that we are actually going to be working on. Same here, upload changes, and then it's time to go back to work on the field. Here we will basically see the same thing. We have all our projects that are there. We'll see which one are available on the cloud, missing locally, or available locally already. When we click on it, there is a packaging job happening, and we can download it. And once we have downloaded, you see the exact same project, just with an optimized user interface in Qfield, where you can start working. Here you can edit you can edit attributes, you can add pictures, you can create new points, and so on and so on. You do all your work that you need to do, and once you're done, you'll see up at the top the little cloud, shows you how many changes you have, how many changes have been tracked, and you'll have the possibility to push those up to the cloud. And once you push them, says that there are no local changes anymore. You can obviously also revert those, and once we're done, we're up to date. We go back to the cloud, and we'll see that we have a new project change. So we have a new point that has been added, or a new attribute that has been changed, and here we have actually a super nice interface that shows us what kind of change has been done. So here we see down on the value that the diameter was changed from 4.1 to 4.2. Really neat. We'll see we have the possibility of showing all the attributes, not only the ones that are changed. By default, we show only the changes because that's the interesting part. Or we can go even further and have a look at the raw JSON that was sent to the application. Why do I mention this? Well, because Qfil Cloud is completely API driven, which means you can just hook to the API and get that JSON and do whatever you want with it. You can get all the picture via API, you can get all the changes, all the job, anything that you can do with the website, you can do via API. In fact, the website is a separate application that speaks via API to Qfil Cloud. So it's really anything that you can do with the mouse, you can do with your APIs as well. We see here that the changes are automatically applied, and that there is a new version available. The date now changed, and I have new data. I still have the overview and everything. And now I can see also that my change that I did in QGIS before was about renaming tree, and here I have custom picture naming. You see that before they were just called JPEG, and now I changed in Qfil Sync some settings so that the custom naming now reflects the layer that generated that picture. So here trees prefix is actually the layer name trees. And here you can use any QGIS expression to do your naming of your pictures. So pretty powerful. We see back in the office, now it tells us, well, you have some changes online, only GeoPackages changes, obviously. And once we pull those down, you see that suddenly the tree here turned from green to red, meaning that it needs some work. If I push a conflict, which we try to avoid, obviously, but conflicts will happen. The best way to deal with conflicts is try to avoid them, so send people to different places if you can. That's the easiest way to manage conflicts. If I push a conflict, we'll see that the job that runs does not automatically apply. I can say here there is a setting that is called override conflicts, and it will always apply the last coming thing, so last come, last wins. But it's not on by default. By default, if there is a conflict, you'll get the situation where the job doesn't run, it says conflict, and then you can go on the job and you can say, well, I want to apply it, I want to ignore it, I want to skip the whole thing together. If I say ignore, it just stays there. I still can see what would have been, but it's not been applied to my new geo package. And if I decide to apply it, you see that it gets applied. I get a new version of the geo package, as I showed before. If by some random situation I do merge a conflict that I didn't want, or I delete things that I didn't want to delete, we keep history. For each file that you have, you can go and get history back. There is a limit, obviously, on the amount of history that you're getting, but you can go there and you can see the version with the date, and then you can just download it, reopen it in QGIS, and then re-push it up as the newest version. You're just basically overwriting the new version with an old version. So it's really powerful there. I mentioned earlier that QField Cloud is API-based. We have a very nice documentation of all the API codes that we have. But we also have a Python SDK and a command line interface that you can use to build your own tools and to interact with the cloud. We do offer QField Cloud as a service at qfield.cloud. It's a paid service. Well, not only, there is also a free part of it. Or you can obviously roll it out in your own cloud. We can help you with that if you need, or you can just take the code and roll it out yourself. The version that we host, it's hosted in Switzerland. In Switzerland, we have the luck to have very high percentage of very good energy. So it's really easy to get data centers that are actually using sustainable energy. And by kind of the geomorphology of Switzerland, there's a lot of rock around, so data centers tend to be very solid. Pricing, we have a community feature, a community plan which has unlimited public and private projects. Basically, it's limited to a small data storage. And then we have a pro version that has more storage and also offers the possibility to have offline PostGIS. And then we have an organization that has a base price per user. The important thing here to understand is that we are invoicing only users that you're actually using. So if you have 20 users in your organization, but you live in Finland or Iceland and you do not want to really do any field work in February, well, you're not going to be paying in February for 20 users. You're just going to be paid the base price. And then if in August everybody is working, you're going to be paying for 20 users. So we want really to make it easy for you to have accounts, but not be invoiced for things that you're not actually using. It's obviously, as I said, customizable. You can do white labeling because it's all open source. We can do it for you. You can do it for yourself if you want. What's next? plenty of ideas that we have, obviously, and that is why they are not written. Looking into area management, so permissions at a kind of geofencing way, publishing of data on WebGIS, creation of tasks management, so plenty of ideas that we have in the back of our head, but we do not want to write them there because they are ideas that we are working on. We went live out of beta in February, end of February, so it's been 3 months now of heavily usage. We have something like 40,000 users on it currently, so we focus really on getting the service to be running smoothly now. If you have any questions, as I said, we have a booth back there. Come by, we are the one with the pole that has little lights on top. And if not, qfield.cloud is where you get all the information. And obviously, you can get in touch with me as well at marco@opengs.ch. Thanks.
Thank you. I'll just see if there are any immediate questions. We'll probably have 5 minutes. Any questions? No? Then you have the email and you
Yes.
can go to the booth.
Cool.
Thank you again.
Thank you very much.
Thank you for joining. We'll hear now about felt work with maps. Go ahead.
Can everyone hear me? Yes, great. All right, hi everybody. My name is Michael Magursky, and I'll be talking to you a little bit about felt.com, a new way to work with maps together on the web. This session kind of has three sections that I'll go through. The first one that I'll talk about is a little bit of history that describes some of the needs that felt is addressing. So I'll talk about some past work in particular that I've done at past jobs, and some of the ways in which that maybe highlights some of the need for felt and where it fits into the world. Next, I'll talk about some use cases and flows, in particular how one would work between tools like Felt and QGIS. And then I'll wrap up by talking about some of the open source dependencies that we have, our contributions back to them, and generally how open source is important to us and what are the ways in which we give back to it. Sorry, there's a little mouse wheel here, so scrolling is tricky. A little bit about myself. My role is to work on data product and engineering at Felt. I've been there since last year. The company as a whole is about 2 years old, so quite new on the scene. Prior to Felt, I spent about 4 years at Facebook, now called Meta, and I'll be diving in a little bit to the work that I did at Facebook and some of the relevance it has to the work today. And then before that, a bunch of other things. I was at a company called Remix for several years where we worked on spatial planning tools for urban planners and transportation designers. Worked at MapZen, worked at Code for America, worked at Stamen Design, overlapped with many folks that are here in the audience, although it's actually my personal first time speaking at a FOSS4G International and also my first time at Kosovo. So super grateful for the opportunity. So let's talk a little bit about needs, and I'll start by talking about projects that have nothing in particular to do with Felt, but really illustrate, I think, our way of thinking of what the gaps are that we're filling. And in particular, what do people need when they work on maps in an organization or on a team? And these are all observations from working on past mapping data and products. And they kind of broadly fit into some of these categories. We've observed a lot of missed opportunities and bad connections around spatial work. We've observed that today's open source ecosystem is very well attuned for individual work. It's extremely powerful, extremely convenient for people to use a lot of the open source tools that we see at conferences like this one in their work as solo developers or solo geographers. But we think that there are some painful gaps that I'll talk about for teams and organizations once you get up above the level of the individual. So the example I'll be using is a project called GeoInsights. This is something that I worked on as an engineering manager at Facebook between 2018 and 2021. You can see some of the output of it still today at dataforgood.facebook.com. And I won't get too far into the weeds on it, but if you're curious to learn more about it, actually it plays a small role in Saeed's keynote that he's going to be doing about the Turkey earthquake response on this stage in about 2 hours. So you may see some hints of this work a little bit later today that's informed by some of this work at Facebook. But the kind of gist of this project is that, Facebook had these big, interesting geospatial problems, as you might imagine, for a company with, 2 to 3 billion users worldwide. I personally supported a team of engineers that worked on a tool for analyzing spatial data. And GeoInsights was the name of that tool. So I'll talk a little bit about it and show some screenshots and maybe kind of show how it sort of charted the path towards how we're thinking about felt. There was a data science aspect to GeoInsights. There was 3 data science PhDs on the team that worked on model creation. One particular one that you can still benefit from today is shown in screenshot here. It's called the High Resolution Settlement Layer, or HRSL, and it's a 30-meter global population grid based on AI and machine learning from satellite imagery that is continually produced by Facebook and Meta in order to show, essentially in very high resolution, where people are settled and where they live around the world based on satellite imagery and building presence. One of the pains and the needs on the data science of this work was that actually, even though these folks are really skilled PhD statisticians, people that are very adept at working with numbers and tools like RStudio, they actually didn't have a whole lot of geospatial knowledge and access to geospatial tools on the team itself. So they were kind of inventing things from scratch in a lot of cases because they didn't really have access to kind of common data sets and tools that they may have learned about in a more GIS-style education. But they were able to produce really fantastic work. This is a screenshot of one of the projects called Movement Maps. The benefit of this project was, because Facebook had some way to observe how populations moved based on mobile telephone pings from Facebook usage, we were able to share that information with humanitarian organizations, in particular in response to various kinds of fast-moving disasters, to be able to show how people reacted by moving away from and back to perhaps crisis-afflicted areas over different spans of time, which could be used in order to direct things like aid relief efforts, that kind of thing. On the engineering side, there was a team of 5 engineers and designers. This is the group that I worked more closely with. And typically what our work was assembling web-based tools, things like Mapbox, OSM tiles, into a dynamic application. And the pains there also existed. A lot of them really had to do with the pain of reinventing fairly normal UIs from scratch. Oops, wrong way. There we go. But at the same time, even though we were reinventing a lot of stuff, you could still do a lot of really sophisticated work if you had that scale of team working on, in this particular case, raster data for Facebook usage and other kinds of like spatial information about Facebook at a very low level. And then there was a lot of combined pains that came from those 2 teams working together and, again, trying to construct something without necessarily the benefit of a lot of pre-existing spatial knowledge. The data sharing itself was a lot of needlessly custom engineering work. Most of our development effort actually went into permissions control, not even the interesting part of mapping or visualization, but just who could see it, and how can you get this data out of the company to partners at the World Bank and other organizations. And then data would also immediately exit kind of what we called map world. Once this data was in use, it would go into slides, PowerPoints, PDFs, Word documents, and was sort of no longer a map at that point. It was no longer possible to think of it as geographic data. It was just kind of pictures of data, so a little bit dead. Another of the big pains that we found, another of the big needs that we saw, was that even though applications like QGIS were clearly available to a lot of these folks, and Facebook in fact has a fairly strong bias towards open source, we actually found that the understanding for why somebody might use this tool, or even ArcGIS, like a commercial product, was actually really poorly distributed through the organization. So if people happened to be exposed to some of these tools, let's say as master's students or PhD students, they would know to use them, but generally speaking, the knowledge was not widely supported. Meanwhile, a lot of more web-based tools were kind of entering the flow at large organizations like Facebook. For example, Google Docs and Figma have set a lot of new user expectations for what a good team-based development or data editing and data sharing tool should look like. So what are some of those expectations? Google Docs makes things like sharing extremely normal and painless. The ability to get data amongst teams, make it available to people who you work with, make it available outside your group. Figma, which is an in-browser drawing tool, approximately sort of the same thing as Adobe Illustrator, but browser-based, introduces this whole concept of multiplayer. If you're a designer working with Figma, you're seeing your collaborators, cursors moving around on the screen. People are able to direct your attention. You can see the thing you're working on together with other people on your team, and it's a very interactive process, even if you're remote from one another. And then tools like Notion, which is kind of a wiki document together commercial product, introduces this whole concept of feedback, commenting as a really core part of the workflow. So these are the kinds of things that people expect now from their tools and that are not necessarily getting from everything out there. So these are the opportunities we see. The benefits of getting real geospatial tools without an individual having to know personally to install them. Some kind of place for shared team assets in perhaps a data library. Some way to collaborate and provide feedback without leaving the map, without going off into PowerPoint land or PDF land. And then if QGIS flows exist already, how do you support them formally? How do you make sure that they're a part of the work that's happening? So this brings us to Felt. This is kind of the space in which Felt operates. Felt fills some of these gaps. In particular, we've seen the importance of QGIS to our users' work. We've found that for a lot of the users that we talk to, they do a lot of their kind of pre-existing analysis and a lot of their more kind of hardcore data operations in QGIS, and then they bring it into Felt where they do the sharing and collaboration and presentation side of the work. So we've really found that where QGIS wins, Felt wins. And I'll give you a few examples of some work that we've seen in that area. Here's an example from Angelica Rodriguez Arriaga, where she put together a QGIS map of top crops in California, divided up by county, but then brings it into Felt in order to get some of the more kind of informal drawing tools built in, such as that call out for San Francisco, some of the stuff for Los Angeles down in the south, things that you may not have in normal GIS apps, but kind of look a little bit more like drawing people's attention to something or kind of more informally annotating parts of the map. Stamen Design used Felt earlier this year to produce a project called the West Cliff Recreation Area. This is a region around Santa Cruz that's threatened right now, and they used QGIS in order to create some of the shaded bathymetry and some other data preparation, but then in the same way, Felt becomes a way to kind of annotate, label, and produce an artifact for sharing. Yao Hua La in Malaysia produced a project called Makaranga with Felt that pulls together different kinds of environmental reports on crops and other uses of land based on a pretty heavy analysis within QGIS. Joe Morrison at Umbra, actually, wow, this is completely invisible. It's quite a dark image, but he's using some of his company Umbra's satellite imagery within Felt to show where perhaps illegal Amazon mining is happening for gold. So Felt is really part of a complete loop here. People are using it together for a complete data preparation, analysis, and feedback flow. I put together an example that I'll step through that works on a data set called TIMS, the Transportation Injury Mapping System, which in California tracks typically car collisions, and in this case, bicycle and pedestrian collisions. So a typical workflow between QGIS Felt might start with QGIS. Perhaps you're pulling in data from a system like TIMS, or in this case, zip codes or postal codes from an organization like the US Census. You're pulling that together into QGIS and starting to do some early analysis, perhaps doing point and polygon counts, in this case showing which of those zip codes had the most or heaviest numbers of cycling-related accidents. We have recently started publishing a plugin to QGIS called Add to Felt, and this makes it a one-click process to bring those two things together. So if you have a QGIS map, perhaps with several vector or raster layers in it, it becomes a one-click process to turn that into a map within Felt. It gets uploaded, and then you get something a little bit like this. Very similar looking, but now you have a whole lot of new affordances that come from this being a tool that's geospatial, but also on the web. So looks similar at first, you can do a lot of styling and so on there, but you can start to get in and do actually some pretty interesting and creative, more like team workflow tasks. Here, for example, maybe I'm commenting on some of these. Maybe I'm using a polygon drawing tool in order to highlight some of those elements. Perhaps I have other colleagues that are looking at this map at the same time and making comments to each other. So this is where you start to get perhaps people that aren't GIS users, or they're not planners, or they're not part of that QGIS workflow, but they know how to work a web browser, they know how to work Google Docs, and they understand how to do fairly basic kind of commenting, interaction. Maybe they can start bringing elements of media or bits of freehand drawing into the map in order to enrich that interaction. So it becomes a kind of common conversational environment where people can talk and share work. And then you can bring it all back out of Felt, pull it back into QGIS, and kind of complete that loop. It becomes sort of a full tool chain where the analysis and the analytical power of QGIS and then that sharing and collaboration functionality of Felt all sort of comes together. So here's the loop. QGIS and its universe of plugins for really complex analysis. Felt has an API and a feature called Upload Anything for bringing that data in. Our UI quickly displays very large data sets in a fast web view. For those of you who were at Erica Fisher's talk about Tippecanoe yesterday, I'll talk a little bit about that tool in a second as well. Sort of maybe you understand a bit more about how you get this kind of speed and performance even for quite large data sets. We have drawing tools for soliciting feedback, generating new data, and then ultimately that API for turning that data back into geodata that can fold its way back into the more analytical-based flows. So I want to close out by talking a little bit about why open source is important to Felt. We are a commercial product, but we actually have a fairly large number of relationships with open source tools that we either use or support or contribute to in various ways, and I'll talk about a few of those. Here's just kind of a few things. We have ones where we contribute code. There's a few that we support really intensely because they're core tools that are very central to what we do. And then finally, we have organizations that we sponsor directly because they're so kind of important in the lives of our users and that kind of feedback flow. So in terms of contributions, MapLibre and GDAL, or Goodle, both feature very, very heavily in our work. We render via MapLibre. For those of you not familiar with it, there are some folks like Yuri and others that are here from MapLibre at the conference. This is a fork of what was originally the Mapbox browser-based and other map rendering SDKs. We use those as our mapping engine for the in-browser display, and we've contributed in the areas of style, raster, text rendering, and other functionality in order to expand and improve MapLibre as a very strong open source project that helps benefit us. We have a similar relationship with Goodle. Our upload anything raster and vector data upload system is almost to be thought of as a very thin wrapper around the power of Goodle. And where we've found opportunities, for example, by expanding support for archive formats that we contributed up to version 3.7.0, we've tried to bring those back into the kind of larger fold of Goodle to improve it for lots of other users. We also have deeper relationships with tools. This is Erica. Erica's in the audience. There she is waving. Tippecanoe, if you weren't at the talk yesterday, is really, I think, one of the only lossy visualization optimized tiling engines for vector data. Very powerful because it allows you to do things like uploading, let's say, geo packages with potentially millions of rows in them and displaying them almost instantaneously in a web browser because it downsamples, simplifies, and generalizes that data to make it very easy to work with, even as the entire data set is there present behind the scenes. Basically, all of our data passes through Tippecanoe on its way to PM tiles, which I'll talk about in a second. And we've actually picked up its development from Mapbox. Originally created there, Erica joined Felt last year, and we've been issuing new releases after a fairly dry period in Tippecanoe's history. Another core tool that's very, very important to us is PM Tiles, part of the Protomap suite by Brandon Liu. PM Tiles is a new emerging format for tiled data in cloud environments. For those of you who weren't at Brandon's talk yesterday, you'll be perhaps interested to take a look at it as an alternative to MB Tiles and a way to think about how cloud-based environments like S3 or other object stores can work with tremendously large tile sets. Again, all of our uploaded user data flows through PM Tiles, and we've funded directly some expansion work on PM Tiles' ability to read and write in various environments. AWS Lambda in particular is part of our flow, so making sure that PM Tiles bytes can be read via AWS Lambda is very important to us. And then making sure, for example, that Tippecanoe is able to write directly to PM Tiles. I think I also heard from Evan's talk yesterday that it might be supported in Goodle coming in pretty soon. And then finally, we have some open projects that are extremely important to us and that we actually partner with directly. QGIS is huge for us. Felt earlier this year became the first flagship sponsor of QGIS. This is a 3-year commitment that we've made. And in particular, this helps us to support QGIS with some of the less glamorous, more kind of long-term planning and bug fixing efforts that they have to go through. And we do that because these two projects really complement one another. The workstation-based analysis of QGIS is something that's tremendously important to users of Felt and will remain tremendously important to users of Felt. But then where Felt comes in is that kind of web-based sharing, collaboration, multiplayer, and feedback flows that are important once you want to bring your work outside and beyond your GIS group into something more like public comment, public feedback, members of your team that aren't competent with these tools, that kind of thing. Broadly, we think that when QGIS wins, Felt wins together. So really back to the start, what are some of those needs that I talked about earlier, and then how does Felt and a lot of this open source tooling kind of address that? We talked a little bit about how putting together these low-level visualization tools in projects like the one I worked on at Facebook really forces you to reinvent normal stuff from scratch. So Felt is this complete mapping environment for users and teams right in their web browser. A lot of times, even large organizations like the one that I worked in would not have access to geographers on teams or formal spatial tools. So Felt provides a lot of that in this kind of friendly browser-based environment that's very accessible to teams like that. Data sharing and permissions is very hard engineering work. It's unglamorous, it's difficult to get right, easy to screw up, and Felt does a lot of that directly within the tool. And then finally, there's this issue about data exiting kind of the map world. When data gets dropped out into a PDF, dropped out into a PowerPoint, dropped out into a screenshot in a Google Doc, it's no longer a map, and it becomes very hard to bring that back into that full loop that I described that allows that data to stay geographic and stay part of an actual decision-making or informational workflow. So Felt supports that shared work, and that's kind of a key part of what Felt is offering. So that's it. thank you, everybody. Very appreciative of the chance to talk to you today about the project, and really happy to catch more talks today and tomorrow at FOSS4G. And I think we have about 5 minutes for questions. Is that right?
Thank you so much.
Thank you.
All right. Are there any questions? Yes.
Have you considered a more live feedback loop back into QGIS?
Have we considered a more live feedback loop? Absolutely. A lot of our QGIS-related releases are very, very fresh. I think the plugin is perhaps a week old at this point. So our strategy generally has been get this stuff out there, start to see what kinds of demands and expectations people have of it once they get their hands on it, and then use that in order to kind of drive the product and engineering and design work that we're doing. And definitely one of the things that we're hearing is a lot of what you're saying. People who have perhaps regularly updated or live updated or otherwise real-time in some form data flows that they want to see happening moving between the two. So we have an API. It's technically possible for people to kind of self-serve on that, but we're also observing how people use that API in order to determine if that's something that we should be supporting kind of first party.
Any other questions?
Yeah, I was wondering, can you use it with touchscreen or a digital pencil?
Can you use felt with touchscreen or digital pencil? I've not personally done it, but apparently you can. I think we have a lot of users that use it on mobile, which to me sort of expands to like iPad type interactions, and it's definitely possible to use it in those cases. It's a web-based tool, so we rely on the kind of affordances of web browsers in order to do that, but it's possible.
Okay, thanks.
Any other questions?
Thank you for talking. I am amazed your application. One question: how do you think about dynamic tiling? Your approach is mainly focused on static tiling in like typical PM tiles. But origin data has once changed. We have to make PM tiles at all. So I think it is needed to tiling in dynamically. What do you think?
I'm actually not sure I fully understood the question. I'm sorry. Would you mind compressing that a little bit?
Yep.
So,
how do you think about dynamic tiling?
Dynamic tiling.
Yeah.
Oh, yes. Generally speaking, the data that people upload into Felt tends to be sort of a one-time static thing. So we do use certain elements of dynamic tiling, mostly as kind of like an internal efficiency thing. Don't calculate until you actually need it. But I think kind of as to the earlier question, I think one of the things that we're observing is that we have customers that are interested in the idea of data that changes over time. So our perception is, there's obviously a very easy way to deal with that, which is just upload stuff repeatedly, kind of boring. But I think one of the things we're trying to observe is
I missed it. As far as I understood, it's kind of a tool for like teams and collaboration, and I was wondering if there's also like a use case for extracting like crowdsourcing information, like think of development plans, urban development, and you want to like collect data like from citizens there, maybe also anonymous, extract the like comments and feed that back to the urban planners.
Yeah, that's absolutely a use case that we've observed. So in the kind of broad areas of like architecture, engineering, planning, urban construction, things like that, one of the patterns that we very frequently see is the need for community feedback on plans. So we've seen a number of architecture and related firms, planning firms, essentially use Felt to share maps that show different kinds of scenarios or potential plans to people. You know, what if we put this bike lane here versus there? And we've definitely seen evidence of people using it in that way. Our commenting and other features do allow anonymous users or people without accounts in order to participate. So if you set your maps sharing in a way that makes it publicly viewable, you can actually embed it in different places on the web. You can invite people to give you feedback. I think the most sort of extreme example that we've seen is within the last week or so, there's a guy who's doing a walk with his dog across France and using Felt basically to encourage people to set up meeting points to meet the dog and pet the dog. And I want to say that it might be the most heavily used in terms of numbers of people map that we've seen on Felt today. All of them are anonymous. I think the dog's having a great time.
All right, any final questions? No? Well, thank you again. Ah, sorry.
I don't want to be offensive, but do you plan to make this open source at some point, or?
There's elements of open source that we are making available. So I think, very broadly, there's kind of a, division. There's some things that are very much like pieces of the product that don't really make sense in the open source world, and so we're not considering those. But then there's other elements like our use of MapLibre, the improvements that we're making to Tippecanoe, the improvements that we're making to Google, that we try to kind of aim in a direction where they're actually happening down below in those projects that we use, and then pushing them back out into those projects. So things that are kind of, custom to us, probably not. Things that are not custom to us, definitely yes.
No? More questions? All right, thank you again.
Thank you, everyone.